All right, we're back. We're on page 195 math analysis. We are still doing parametric equations. We're going to look at ellipses. Ellipses are really not that bad. They're very, very similar to circles. I think of them as being kind of like, it's basically a circle, but the radius doesn't really stay fixed. That's when you're physically looking at an ellipse, right? So like, because a circle, there's like the one point, the center that's kind of like pulling toward. For an ellipse, there's the two foci, and like both of them kind of have like their own sort of gravity, and they're gonna like try to pull the point toward them. That's one way of thinking about it. That's kind of how I think about it. Parametrics for an ellipse are basically identical to the parametrics for a circle. We do a little less because it's a little harder to like conceptually work out some of the things with an ellipse, and so like we do enough, so we don't really need to deal with that. But we are going to use the same Pythagorean identity, right? Cosine squared, sine squared plus cosine squared equals 1, or cosine squared plus sine squared equals 1. Now, the reason that we can do that is because an ellipse has like a thing squared plus a thing, let's say thing sub 2 squared equals 1, right? So we're able to just equate those and kind of go with it. So it's going to work. Let's see if we can do this. So write a set of parametric equations for each of these ellipses. So this is a sort of review. So I'll do this like the annoying way, and then I'll do it the easier way, or what I consider to be the easier way. So we could say that x minus 8 over 25 is x minus 8 over 5, because we got to square root it, is equal to cosine or sine. It doesn't make a difference. So then x is going to be 8 plus 5 cosine, but it could have been minus 5 cosine. Again, doesn't matter. Y plus 3. I mean, it matters in the context of the problem. Like, are you supposed to start at a certain point and go clockwise, counterclockwise? Like, what's your deal? But in this case, we don't know. So we can just do what we want. So sine, and then you'll get y equals negative 3 plus 4 sine, or minus 4 sine. Doesn't make a difference. Again, with that caveat that it makes a huge difference. So here's how I prefer to do it. In the absence of any other directions, which is really your best case scenario. Why am I writing cosine twice? What are we doing here, people? Okay, here. So the way I prefer to think of it is the center. So 8, 3. And then I like to think like, how far can you go in the x direction? And that'll just be with x. And then how far can you go in the y direction? And it'll be that. So if it was a circle, you would be able to go the same amount in both directions. But like in this case, the maximum you can go in the x direction is going to be 5 because it's square root of that. So that's your 5. The maximum you can go in the y direction is going to be 4 because it's the square root of 16. So that's going to be 4. So over here, if I had to write these, in the absence of any other directions, which is like, again, your best case scenario, negative 9, 6 is your center, plus 14. I'm going to go with cosine because nobody told me to do anything else, plus 15 sine. So that'll do it. So for this, it's going to start like here, and then you can go, I regret. You're going to start here, and then you're going to go counterclockwise because the cosine sine, that's standard unit circle. You can go more in the y direction than you can in the x direction. This is like a pretty circular thing, but I'm going to draw it at a really extreme. So this is 14. This is 15. So you can tell like really quickly what kind of ellipse you're getting. Like, is it horizontal or is it vertical? Because it's a little more obvious. Well, I don't know. I think it's a little more obvious because of the amplitudes of the trig functions. Like those are how far you can go. So in this picture, like this would be 5 and this would be 4. All right, let's try the next one and see if we can work it out. So what are we supposed to do? Graph the ellipse, indicate the times at which it's at the vertices and covertices. Okay, so here, so to graph it, you don't really need to know anything about time. You just need to know the center. So our center here is going to be 3, 5. So 3, 5. All right. And then I can go 4 in the x direction because of this. So I'm going to do that. So this will be, let's say 7, 5, and then try to go the same distance, -1, 5. And then I can go, so those are because of that. And then that being the color coding. And then here, I can go 6 in the y direction. So this is going to be, let's say up here, 3, 11. And then it's going to be in the middle of the problem, but that's okay. I'll just pretend it's not. 3, -1. And that is because we can go 6 in the y direction. Now, where are we starting? X is a negative cosine. Negative cosines start at the minimum, so you're going to start at the minimum x. There's a minimum, middle, and a maximum. So we're going to start here at t = 0. But how long does this take? Good question. Period is 2 pi over b, so 2 pi over 2, which is just pi, and that is because of this. Okay, so it takes pi. So we're here at t = 0, and then, so what's y doing? Y is a positive sign. So a positive sign starts in the middle and goes up. So your y options are middle, minimum, maximum. So it starts in the middle and goes up. So we're going this way. So it'll be like here. We're going to get here at pi over 4 because it's 1/4 of the journey. Here, we're going to get here at 2 pi. I'm going to write 2 pi over 4. I know it's pi over 2, but it's a little easier to work out if you write it that way. We'll get here at t = 3 pi over 4. And then finally, we'll get back there at t = pi because it takes pi to go around. So, I mean, I think it's like, I really like working with ellipses. I feel like they're very straightforward from a parametric perspective. All right, let's do the same thing. So -4, 5 is our center. So let's start with that. And then we can go 5. You can only go 2 in the x direction, but you can go 5 in the y direction. So this is like a really vertically stretched ellipse. So maybe I should label things. -4, 5. Then I can only go 2. So let's say this is -2, 5. And this is -6, 5. And then I can go 5 in the y direction. So that's really big. -4, 10. And then we'll pretend again. I can go 5, so -4, 0. All right, where do we start? X starts in the middle. So like here. So that doesn't really tell me because I don't know if I should start here or here. I just know that I'm starting in the middle. And because it's positive sign, it's going to increase. So I'm either doing this or I'm doing this. I don't know which. But when I look at y and I see it's negative cosine, that means I must be starting down here. So we'll be here at t = 0. And then we said that x is going to increase because it's positive sign. So it's got to go this way. So we'll do this. What's the period? So the period is 2 pi over 3, so 6. So 6 divided by 4 is 1.5. We'll get here at t = 1.5. Bad ellipse. We'll get here at t = 3. We'll get here at t = 4.5. And then finally, we'll get there at t = 6. And we did one full revolution, and it's just going to keep going. Not bad. Okay, I'm going to stop this video here and come back in the next one and talk about the next problem, because the next problem I think is really interesting and kind of worth its own video. So I will be back to finish this page, and I will see you then.